Let's continue our discussion about Python functions. At the end of the previous video, we started to talk about applications that involve an arbitrary number of input arguments, right? So in some situations, we probably in some applications we may not know in advance how many arguments are going to be passed in, right? If that's the case, we can use this kind of the so-called variable length arguments, which is basically just the name of tuple prefixed with a star. Sometimes it's called exploding operator. So this exploding operator is going to collect all the once all the positional and keyword arguments are being matched, the remaining any remaining arguments are going to be collected into this tuple, basically, right? And in some applications, we are unaware ahead of time not only just the number of arguments, the number of input arguments that will be passed in, but also the kind of information, the type of data that will be passed into the function. And in this case, we can write functions that accept an arbitrary number of key value pairs. The syntax is actually similar to the one that we used for passing an arbitrary number of input arguments, except that now we need to put 2 stars in front of parameter. So let's look at how the syntax works. Let's define another function. Let's call it hello print 8. First name, last name, and then star other info. And that's going to be the definition line of our function. And inside of the body of the function, the first thing we're going to do is to define a dictionary. Define an empty dictionary that's called info, right? And then we're gonna set the key that's first name of the info dictionary to first name. We'll convert it to title case, and then info last name. Okay, we are inserting the first name and the last name keys into the info dictionary, and then together with their corresponding values. Last name dot title. Right, we're converting both the first name and the last name into title case, and then inserting it into the info dictionary with the key first name and last name as their key. Right, and then this other info is going to be used to collect all key value pairs that's passed into this particular function. So other info inside of the body of the function, we can use other info as a ordinary dictionary. So for k, v in other info dot items info k equals to v. So basically, we're just copying all the key value pairs from other info into info. Right? And in the end, we can sort of do a print hello and then info. Right. So the definition of this function is going to expect a first name and then a last name as positional arguments, and then it allows the user of this function to pass in an arbitrary number of key value pairs, and all those key value pairs will be collected into other info, which is actually just a Python dictionary. And inside of the body of the function, we can just use it as a Python dictionary. Right? It's a normal Python dictionary, and so we can actually call this items method on this dictionary to access all the key value pairs that's stored inside of it. Right? So here we are actually creating a new dictionary that's called info, and then add the first name and the last name in title case to the dictionary, and then we just loop through This is a for loop, right? We just loop through all the key value pairs inside of the other info dictionary, and insert those key value pairs into the info dictionary, and then we print out the content. Print out the content of the info dictionary in the end. And when we are calling this function, we can pass in the first name and the last name as positional arguments, and any additional key value pairs are going to be collected by the other info dictionary. So let's call hello print 8, right? That's gonna be the first name. So this string is gonna be matched with the first name, and this string is gonna be matched with last name, right? And then all the remaining key value pairs are gonna be collected into other info. So say age equals to 76. That's one key value pair, right? And then country equals to USA, right? That's another key value pair. So both key value pairs are gonna be collected into other info. And let's just run it. It's probably a better idea if I print a separator first. Right. So hello, that's from this hello, right? And then info is basically this dictionary. First name Bob, last name Dylan, with title case. Age 76, right? That's from here. That's from this key value pair. And then country USA, that's from this key value pair. So both key value pair goes into other info, this dictionary. And all the items, all the elements inside of all the key value pairs inside of the other info is being copied into this new dictionary called info, right? And then here we're actually printing out the content of the info dictionary. So age 76 and country USA are going to be printed out as one of those key value pairs in the info dictionary. Right. And the function will work no matter how many key value pairs are provided in the function call. So suppose we call again print A, but with some different inputs. This time we're gonna sort of use some slightly different syntax. So last name, that's a key value pair actually. And then first name, country, and then deceased equals to true. Right, so here we have added, so in addition to last name and first name and country, we have added another key that's called deceased, and it has a Boolean value, right? That's true. And in this particular code, we are not having an age key value here, right? So let's run it. And the code will still work without any kind of problem, right? So first name Johnny, last name is Cash, country is USA, deceased equals to true, right? So if we are actually using keyword arguments, here we're actually using keyword arguments, right? So the ordering of the input arguments really does not matter anymore. So we can just mix all the input key value pairs in any way we want, actually. So it doesn't really matter. We put the last name in front of the first name, right? Because these are keyword arguments. So the first name is still going to be matched with first name. Last name is still going to be matched with last name, and then everything else is going to go into other info. Right. So now let's do a slightly more complicated call. Print 8. Right. Country equals to Canada. Right. So we're putting country as the first input argument, but position doesn't really matter anymore because we are using keyword arguments. Right. And then first name equals to Leo, and age equals to 71, right? We're putting an age in front of a last name. Last name equals to Young, and then let's add another key value here. That's called spouse equals to Peggy Young, right? And then let's run it. And it's still gonna work without any kind of problem. And all the key value pairs are correct. First name Leo, last name Young, country in Canada, age 71, and spouse Peggy, right? So if we are actually using keyword arguments, then the ordering of those arguments doesn't matter, right? So first name is gonna go into this position argument, the keyword argument first name here. It's gonna be matched there, and then last name is gonna be matched with the last name here, and then all the remaining key value pairs are gonna go into other info. So in all the examples that we have been writing so far, the results computed inside those functions are immediately displayed by the functions. Right? A function does not have to actually display its own results directly. It can process its inputs and return the results back to the caller, which can be another function. And the caller can then decide what to do with the returned results. It can display the results or sort of process it further. Right? So the value returned by a function is called return value. So now let's talk about return values. Return value is a function. Basically, a function can actually return any kind of data type. It doesn't have to be a simple data type. It can be a composite data type. It can be multiple data that's combining into a composite data type, right? So for example, we can make this hello print 8 function return the dictionary info that is constructed inside of the function, right? So basically, we can just let's just copy and paste it. Let's call it, instead of print 8, let's call it return 1, right? And then so let's make some changes to it. Here I'm gonna, instead of printing this thing, I'm gonna print ID info and then return info. Right. So we have changed the function name from hello print 8 to hello return 1. The print statement has been so this print statement has been removed. We are not really printing the content of the info dictionary directly inside of the function, right? And then the info dictionary is now being returned back to the caller by using this return Python keyword. So everything that's following this return keyword are going to be returned back to the caller. So when we call this function, we can actually assign its returned value to another variable. Say, let's call it musician. So we can call this function now with an assignment, within assignment. So let's define another variable that's called musician. Musician equals to hello return 1. Let's just copy this thing. Right. So what's actually happening on this assignment is that this hello return 1 is going to return the info, return the dictionary info to the caller, right? And then you can actually basically just replace the entire call with just the return value, right? And then this return value info gets assigned to this new variable that's called musician, right? So we can print out the content inside of the dictionary musician, and also its ID by calling the ID function, right? So we have looked at the ID function in the third video, right? In the third video, when we talked about deep copy and shallow copy, we were using the Python built-in ID function to check if two names are actually pointing to the same object inside of the memory space, at exactly the same memory space, right? So here again, we're actually using the ID function to look at if info, that's the name of the dictionary that's constructed inside of the hello return 1 function, and this musician 1, do they have the same ID or not? Right? Let's run it. So here, that's the ID of the info dictionary that we printed inside of the function hello return 1, and then here, that's the ID of musician that's printed here, and then followed by the content of the musician. So first name Neil, last name Young, country Canada, age 71, spouse Peggy. And we can see that the ID of the musician dictionary outside of the function and the ID of the info dictionary inside the function are actually identical, which means that they both point to the same dictionary object at exactly the same memory address. So this assignment of the return value from the hello return 1 function to the dictionary musician is actually a shallow copy, right? Python does not allocate new memory space and copy over all the content of the info dictionary into musician, the musician dictionary. Doesn't do that. It only creates another name that's called a musician, and then points this new name, musician, to the dictionary object that has already been allocated and constructed inside of the hello return 1 function. Right? And a dictionary is just one data type that a function can return. And another data type that can be used to bundle together multiple pieces of data for returning is the tuple. Now let's write a function that will return the full name of the musician with title case, together with the age, if there is a keyword argument for age. So now let's define another function, def hello. Let's call it return 2. It's gonna accept first name, last name, star other info. And then full name equals to just first name plus space plus last name, and then dot title. And then we can sort of do a print. It's called hello plus full name. Okay. And if age in other info, so here might be something that you haven't seen before, right? The conditional test that's inside of the if statement. Let me finish writing it, and then I'll explain what this thing actually means. We're gonna return full name and then other info age, else return full name unknown. Right. So the conditional test, this thing here, inside of the if statement, this is actually an example of the so-called membership test. And we're actually checking if the key age is inside of this other info dictionary or not. And if it is a key in the dictionary, then this conditional test is going to be evaluated to true. And we're going to execute this line. And this line is basically returning full name and then other info. We're returning the value of the other info dictionary associated with the age key, the value corresponding to the age key inside of the other info dictionary, right? Otherwise, we're going to execute this line. That's going to return the full name, and then with another string that's called unknown, right? So it may appear that both return statements here are returning two objects, But if you have watched my third video in this sequence about Python, you will know that the code actually following the return keyword, the return Python keyword, is actually one tuple. So this comma separated sequence is actually a tuple. Even though it looks like it's two objects, it's actually one tuple. So this function is actually returning one object, that's one tuple, which actually has two elements packed inside of it. And when we're calling this function and assigning the return value to two variables, for example, let's call this function. Right. So we're calling this particular function. And then let's just print this one, name plus age plus str, just in case the age is an integer. Let's do a conversion to the string. And the two elements inside of the tuple, right? When we do this assignment, the two elements inside of the tuple are actually being unpacked into these two variables. One is called musician name, and the other one is the musician age. So there is actually a tuple packing at the return statements inside of the function. And there is a sequence unpacking process during this particular assignment of the returned tuple to these two variables. So in fact, this if-else construct can actually be replaced with just a single line of code by using the get method on the other info dictionary. So all we have to do, let's comment out these lines. Right. Comment out these lines. So it's gonna return, we're gonna return full name, and then as the info.get, we're calling the get method. So let's just run it. So it tells us Neil Young, age 71. This hello Neil Young actually comes from this print, right? It might be a good idea for me to actually print it separately first, and then rerun it. Just do a force reset, and then rerun it. Right. So hello Neil Young, age 71. Right. And what exactly does this get method do, right? What this get method actually does. The get method will actually check the existence of the first argument, which is age here. Right. This first argument is the requested key. It's the requested key. We want to get the value of this particular key. Right. If this key exists, the get method will return the value corresponding to this key. Right. But if the requested key does not exist in the dictionary, then this get method will actually return the second input argument, which is the default value. And here it's set to the string unknown. And suppose we actually, here we have a age equal to 71 inside of the, as one of the input arguments in the code, right? Suppose we get rid of it, right? And then let's rerun it. Let's rerun it. And here you can see Neil Young, age unknown, right? Because we didn't actually input the age. We actually didn't actually put an age as a keyword argument to the when we actually called the hello return to function, right? So that's sort of the behavior of the get method. on the dictionary, right? It's either gonna, if it finds the requested key, it's gonna return it. If it's gonna return the corresponding value, right? If it does not find, if it cannot find this requested key in the dictionary, then it's gonna return the second argument. Here we set to unknown, right? So in addition to the return types given in these examples, we can also return strings, numbers, lists, or any other data types. There's no sort of restrictions to the data types that you can return from a function, right? And all we have to do is to put those objects we want to return behind the return keyword. And the functions that we have written so far, we have written so many functions actually in this particular source file, right? All those functions that we have written so far can be stored in a separate file called a module, and then we can import that module into other Python programs without explicitly copying all the function definitions. So a module is just like a library. It's a place for you to store all the definitions of different functions. And when you try to use any of those functions inside of another program, all you have to do is to actually import that module into your own program. And then all those functions inside of that module is exposed inside of that program that you are writing. And then you can use any of those functions without copying, sort of manually copying the content of that, or the definition of that particular function into your own program, right? So how do you actually create a module? To create a module, all we need to do is to actually collect the definitions, all the functions that we have written so far, into a separate file. So suppose we would like to create a module named hello.py to store all the functions we have written so far, right? So all we need to do is to actually first create an empty file. Let's create an empty file, and then let's rename it. Let's save it as. Let's save it on the deck. Let's save it as hello.py. So now I have an empty file that's called hello.py. Right. And then all I have to do is to just copy the definitions of all the functions that I have written so far into that particular file. Right. Let's just make a copy. But what we need to remember to do is to actually remove all the lines that call those functions from the module file. We only want to keep the definitions of those functions. We don't want to keep those lines that don't belong to the definition of any function, right? Such as those lines that actually cause a particular function, right? The comment lines are okay, but the lines that actually cause a particular function is not supposed to be included inside of a module. Right? We only want to include the actual function definitions, basically. So let me just delete all those lines. So let me take a look. Let me just double check if I have deleted everything. That's not a definition of a function. Okay, so now we can save the file, and that's going to be our module. That's called hello.py. Right? And there are several ways for us to actually reuse the functions defined inside of a module in other Python programs, for example. Right? And first, let's create a new Python program. And let's call it hello Again, let's store it on desktop. It's called a hello import example.py. Right, let's hello importing example.py. Right, and this file has to be in the same directory as the module file. That's hello.py. For now, both of them are actually on the desktop, on my desktop. Right, so you have a file explorer here. Right, and this file explorer allows us to suppose I go to desktop, I should be able to find both py files. Hello.py, right, that's one file, and then hello underscore import underscore example.py. Both the module file and the program that's going to use the module file are in the same direction now, right? So if we want to import the entire module into this new program, all we have to do is to type import hello, and that's it. So now every function inside the hello module is exposed in my hello import example program. And we can call any of those functions. So suppose we call hello print 8 equals to cache first name equals to, and then country equals to USA, and then deceased equals to, right? So that's calling the hello underscore print 8 function inside of the hello module, right? Let's give it a run and see if it's gonna work. Yes, it worked out. Okay, worked out okay. And then let's try to call another function. This time we're gonna call return to musician name. Maybe it's sort of faster for me to actually just copy it over. Right, that's the second example of how to the syntax error. So this hello Neil Young is actually coming from hello return to. Right? This is a printout from the hello return to. There's a print here, right? And then the output is being assigned to musician name and the musician age. So if we want to look at the musician name and musician age, all we have to do is to do another print. So maybe it's a good idea for me to just print, copy this line over. Yeah. And yeah, Neil Young, age unknown, right? So it looks like the import has worked, right? The only thing that we need to pay attention to here is that when we actually call a function from the module, we need to prefix the function name with the module name and the dot, right? The module name, that's hello, it must match here. That's the name of the module, right? And then the dot, and then the name of the function, right? Here, the same thing. The name of the module dot, followed by dot, and then the name of the function inside of that module. So that's the syntax. So if the module name is sort of too long, so suppose for now it's like 1, 2, 3, 4, 5 characters. Some of the modules could have very long names. For example, TensorFlow, that's like a long name. Right? Prefixing the module name for every function call will involve a lot more extra typing, which can be error prone. If you have to type a lot, there's a higher chance that you're going to make a mistake. Right? So Python allows us to introduce an alias for the imported module. So all we have to do is to sort of import hello as, use the as Python keyword, and then follow as with an alias. Let's just call it an H, right? And then the name after the as keyword is actually the alias of the module name. And now we can prefix all the function calls with just this shorter alias and the dot, right? So we don't really have to do this hello dot anymore. All we can do is h dot, right? And then h dot, and the function and the code will work exactly as before. Right? There's no difference in terms of the result. Sometimes we want to use only a few specific functions from a module. We don't want to sort of use all the functions inside the module. We just want to use just a few specific functions inside the module. So in this case, we don't have to sort of import the entire module into the program. We can only import the functions that we need. So if that's the case, we can just replace this line. Let's comment out this line, right, with another syntax. From, again, it's a Python keyword. From hello, that's the module name of the module. Import hello underscore return to hello underscore print 8. In this case, if that's the syntax that we are using for importing functions from a module, then we don't need to prefix the function names with the module names at all, right? We can just call those functions as if they have been defined in this particular file, in this hello import example file, right? We can just remove the prefix, the dot, and also the module name. We can just do that, right? We can just use hello print 8 and hello return 2 as if they are defined inside of this same file, and the result will be should be the same. Return. I think I made a typo here. Right. So now it looks like it's correct. Right. So that's sort of a third way for you to actually use functions from a module. Right. And if the function names are too long, right? Here, hello return 2, hello print 8, those are very long function names. I myself actually made a typo when I was trying to import those names, right? So if the function names are too long, and we need to call those functions very often, we can also assign aliases for the function names during the import, right? So let's again comment out this line. Right? Let's from hello import hello return to as hr2 from hello import hello print 8 as hp8. Right. So now hr2 and hp8 are sort of the aliases of those two very long function names. And when we try to call those functions, we don't really have to use the hello return 2 anymore. We can just use hr2, right? And here, when we're calling hello print 8, we don't really have to sort of use the full name. We can just use the alias hp8, and then the function, the code will work correctly, right? It will still work correctly. And there's no prefixes are needed in this situation either. So we have talked about how many ways of using functions from a module. Four different ways, right? 4 different ways of using functions from a pre-written module. And once we have introduced functions in the modules, it is a good time for us to talk about another very important concept called scopes. Scopes. Maybe I should write it in this way. Right. Scopes. Scopes. Right. So by now we are probably used to using names to represent data and functions, right? Every function has a name, and we are assigning data to variables, and all the variables have names, right? So everything has a name, basically, and every variable has a name, and every function has a name. Right? But what if we have 2 variables with the same name but different values? And what if we have two functions with the same name but different definitions? And what if we have a variable and a function that have the same name? Right? What's going to happen? What's going to happen? Here we're actually writing lots of codes. Right? If different codes are written by different people and then eventually merged together, and those different people happen to use the same name to refer to the different things, very different things, then what's going to happen? Right? What's going to happen? So you can sort of, if this kind of situation is not handled correctly, the consequence could be quite bad, right? When we talk about the scope, we are actually always referring to a certain name. So the scope of a name is actually the area in our code where this particular name is visible. So now we have a module that's inside of the hello.py, right? That's our module. That's a module, right? So if we define a name that's called a greeting and assign the string hello to it, outside of the definitions of all the functions in this module, let's do that. Let's do that, right? Suppose we define a variable that's called a greeting equals to hello with a space. Right? So if we do that inside of this hello.py module, right, so this assignment is outside of the definition of all the functions in this module, right? And this variable greeting now has the so-called global scope, because now the variable greeting is visible and can be referenced in all the functions inside of this module. This is called a global scope, right? And the reason is that this variable greeting can now be referenced and can be used inside of every function in this particular module. That's called hello. In fact, we can actually use the variable greeting to replace all the string literals hello. For example, we have a string literal hello here, another string literal hello here, right? We can actually, now because we have a global variable that's called a greeting, and this variable actually represents this string literal hello. It has the value in it. So there's no reason for us to actually keep using this hello string literal. We can just use this variable, right? And this variable is actually visible in all the functions. So let's just do a replacement. So edit, search, replace text, right? We're gonna replace single quote hello with a space with greeting. Right. And then let's replace all the double quotes hello also with greeting. Right. I think that's all the occurrences. Now let's save the file. Right. So here inside of hello print 1, we're not printing hello plus username anymore. We're printing greeting plus username, right? And where greeting is actually defined, it is defined outside of this function. It's actually defined outside of all the functions. It's defined here. But inside of the function, we can actually use this particular greeting variable, right? And what about hello print 8 that we're actually using here, right? Before we did the replacement, it was hello here, right? But now it's a greeting. Where greeting is defined, it's defined outside of all the functions at the beginning of this particular module file. And then hello return 2, again, it's printing out greeting plus full name. It's not printing out hello plus full name. Right? Now let's go back to this function that actually uses those use this particular module, and it runs okay. right? It's not really. Let me reset everything. And then clear out. Right, and then let me rerun it. Yes, right. The printout is the exact same as before. See the hello here, the hello here. Right. It's not sort of. There's no difference with before. It works exactly the same way as before. Right. And here we have factored out this particular string literal into this global variable that's called greeting. So now let's look at hello print 8. Hello print 8. Let's look at this particular function. Right. Now suppose inside of this particular function hello print 8, let's define the variable greeting again. And we're gonna assign it a different value. Right. Hola. And then now what's going to happen? So inside of this function hello print 8, what's going to be the value of the variable greeting? Do we have a name conflict? Do we have a name conflict? Because the global variable greeting with the value hello that's defined at the beginning of the file here, right? This greeting, the global greeting, is also visible, right? It's also visible inside of a local inside of a particular function. Here print 8, right? Hello print 8. It's also visible here. And by assigning Ola to this greeting, are we actually changing the value of the global greeting? Right? Do you see the question? Do you see the question? So inside of this particular function, the global greeting that we define at the beginning of the file is also sort of visible, right? And then by doing this kind of assignment, are we changing the global greeting, the global variable greeting? Are we changing that the value stored inside of that global variable, right? What Python will do is that it will actually create a new variable with the name greeting. It's gonna do that. It's gonna create a new variable that's called the name with the name greeting at this particular line, and then assign Ola, the value Ola to it. But this new variable is only visible inside of the hello print 8 function. Let's just run it. So let's save the file first, right? And then in this particular hello import example file, we're actually calling both HP8, which is hello print 8, and also HR2, right? HR2, did we make any changes to HR2? No, we didn't actually make any changes to HR2, hello return to, right? So it's gonna print greeting plus full name. And this greeting is supposed to be the global greeting, the global variable greeting that's defined at the beginning of the file, right? Because inside of this hello return to, we are not really introducing any other greeting variable, right? We are not introducing any other variable that's called greeting. That's the only greeting, and this variable must come from the global variable called greeting, right? It cannot be coming from any place else. Let's just run this thing, run this code, and see what's going to happen. So this is Ola. This is the printout from the hello print 8. So this printout is actually from hello print 8, which is from this particular function. It's generated by this print line, this print statement, which is greeting info. And the greeting here that's being printed has been changed to Ola, and then followed by the content in the info dictionary, right? And then inside of the hello return to, again we are calling print, and then greeting plus full name, and that's this line. So greeting is still hello, and then followed by the full name Neil Young. See? So by doing this assignment here, we're not really changing the value stored inside of the global greeting. So this local greeting, which is only visible inside of the hello print 8 function, this particular greeting is not going to be visible outside of this particular function. So when we actually call hello return to, this greeting is still going to be the global greeting that we defined at the beginning of the file. It's not going to reference the local greeting here that's defined inside of hello print 8. And when we call hello return to from the hello import example, the screen printout generated by this particular function is still going to show hello. It's still going to show hello, right? Followed by the full name of the musician, which proves that the global greeting is not really modified by the local assignment here. By the local assignment that happens inside of this hello print 8, it's not affecting the global greeting variable in any way, right? So by now we have introduced 2 different scopes in Python. This local greeting, which is only visible inside of the function, is said to have the local scope. And the global greeting, which has a value of hello, and it is assigned at the beginning of the file, right, is said to have the global scope. And Python also has another scope, which is called the built-in scope. And inside of this built-in scope, there are about 140 names that's predefined by Python. So if we want to look at the names defined in the built-in scope, what we can do is that we can import built-ins from the inside of the console, and then we can call a function that's a built-in function, drr built-ins, and then it's going to display all the predefined names inside of Python. So whenever we actually use Python and we load the Python environment, all those names, about 140 of them, are going to be loaded automatically. And we actually have seen some of those names, right? For example, ABS, that's going to compute the absolute value of a number, right? And then dict, DRR, we just saw DRR. We're using DRR to actually create this particular printout, right? And len, see, that's the function name for computing the length of a list or something, right? That's all the names that's defined in the so-called built-in scope. So we basically have 3 scopes inside of Python. The local scope, which is inside of a function, and then the global scope, which is inside of a module but outside of all the functions, and then the built-in scope, which has 140 names also, so it's defined by Python, predefined by Python, right? So whenever Python sees a reference to a particular name, for example, whenever it sees a reference to greeting, for example, here we're actually using greeting, right? It will first search the local scope in which the name is referenced. So greeting is referenced in this particular hello print 8 local scope, right? So Python is going to start searching for an assignment to greeting inside the local scope first, right? If it finds one, for example, in this particular example, it's going to find it, right? It's going to find a assignment to the greeting variable inside of the local scope, right? And the value assigned to it is order, right? So if it actually finds an assignment to that name in this local scope, it's going to use that value assigned in the local scope, and then stop searching further. It's not going to stop any further. Right? Once it finds one, it's going to stop searching. But if it cannot find an assignment inside of the local scope, suppose inside of return 2, again, it's referencing greeting, right? And then Python is going to search the local scope. Is it going to find an assignment to greeting inside of the local scope? No, it's not going to be able to find it. There's no assignment to greeting in the local scope inside of the function hello return 2, right? And then Python is going to search the so-called enclosing scope. Enclosing scope. So what does that mean? What exactly does that mean? Right. Python actually allows nesting a function inside of another function. So it's possible to actually define a function inside of another function. Right. You're going to see a def inside of another def. So you're going to see a def of a function inside of the body of another function. Basically, that's a nesting. So Python actually allows that. You can nest a function inside of another function. The enclosing scope refers to the local scope of the enclosing function. So suppose you are actually nesting this hello return 2 inside of another function, say hello return all, right? And then the local scope of hello return all is going to be called the enclosing scope of hello return 2, basically, right? So the enclosing scope actually refers to the local scope of that enclosing function. And if the function is not really nested inside of another function, or Python still cannot find an assignment inside of the enclosing scope, then it will search the global scope of the module. Right? In this case, hello return 2 is not enclosed, is not nested inside of another function, so there's no enclosing scope. Right? And then if it is nested inside of another function, and Python still cannot find an assignment to greeting inside of that enclosing scope, then Python is going to search the global scope of the module. Right? And in our case, it's going to find it. It's going to find an assignment that's at the global scope. Right? And it's going to stop searching right away. Right? Once it finds it, it will stop searching right away. Right? But if Python still cannot find an assignment to the name in the global scope, then it will search the built-in scope. It's going to search these 140 names, 140 or so names, right? It's actually 148 or 142 names, actually, right? It's going to search the built-in scope. And if it still cannot find the definition in the built-in scope, it will report an error. It's going to tell you it cannot find a definition for that name. And this process of searching for the definition of a name inside of a successively larger scopes is called name resolution. It's called name resolution. And the name resolution process for Python follows the so-called LEGB rule. The so-called LEGB. Right, that's 4 letters. L is for what? For local. E is for enclosing. And G is for global. And then B is for built-in. Right? So it's going to search these 4 scopes in sequence. And as soon as it finds one, finds a definition, then it's going to stop searching. Right? But that's going to be, LEGB is going to be the order that Python is going to go through to search for a name, to search for the definition of a name. Right? So we have seen that inside of the local scope, right? Inside of the local scope of a function, we can reference or access, right? It's actually using a global variable, right? Such as the global greeting that's being used here, right? And if we actually make an assignment to greeting, if we actually do an assignment, for example, like what we are doing here, right? If we make an assignment to greeting inside a function, a new local variable that with the name greeting is going to be created, right? But what if our intention is actually to assign the global greeting a new value from inside of a function? How can we actually do that, right? So what if the intention was actually to give the global greeting a new value here, right? The intention is not really try to create a new local variable that's called greeting, but the intention is to actually reassign the global variable greeting a new value, right? So how do we actually do that? Right? If we just do this thing, it's not gonna work, right? Because Python is gonna create a new local variable that's called greeting, right? That's not our intention. So how can we actually do that? How can we do? So here inside of the hello module, let's add a new function that's called change greeting, and then it's gonna take a new greeting as input, right? And if we would like to actually set the global greeting to a new value that's inside the new greeting, this input argument, the input parameter, then we must add a declaration line telling Python that we want to reassign the global greeting. So that's the declaration line. That's global, it's a Python keyword, followed by the name of the variable that we want to reassign. Right? If we just want to reference or use this global variable, then we don't need this line. We don't see this global greeting in the hello return 2, right? Because here we're only using the global greeting. We are not trying to reassign it to anything, right? But here, we want to reassign the global greeting to a new value, right? And we must do that. We must add this declaration to say global followed by greeting, right? If we have more than one global variables that we want to reassign, we can just use a comma and then follow and add all the rest of the global variables we want to reassign, right? The names of those global variables. And now we can make the reassignment. So greeting equal to new greeting. That's the new assignment. So now, after executing this particular line, the global greeting is going to be reset to this new underscore greeting. And let's save this module and then go back to the hello import example, this particular file, right? And here we're going to try to use this change module, change greeting function. So from hello, before we do that, let's import it. Import change greeting, right? And then we can call this function change greeting with a new input. Let's call it order with a space, right? So now, if we rerun this particular code, then both the printout from HP8 and also the printout from HR2 are gonna say hola. So that's hola, and then that's another hola. And the reason both of them are hola is because the global greeting variable has been changed, right? So let's comment out this line, because I believe this hello print 8 is still going to use this local greeting, right? Let's comment out this line, so it's not going to use the local greeting variable, right? So here it's going to use the global one, right? And then here it's going to use the global, greeting again, right? So let's save it again. save the module variable, and then let's reset everything, and then let's clear everything, and then let's go back and rerun it, and then Ola, right? This is because the global greeting value, the value inside of the global greeting variable has been changed to Ola through this particular function call, change greeting. Through this particular function call, change greeting to Ola.